This video is about composition of transformations. Okay, so composite transformations. So you already know how to complete translation, reflection, rotation. And so today we're going to put multiple transformations together to the same figure. And that's what composite transformations are. So we're going to translate triangle QRS. Q, R, and S are these coordinates. By the rule, xy goes to x minus 3 and y minus 4. Then we're going to rotate Q prime, R prime, S prime 270 degrees counterclockwise. Okay, so let's start off by writing our rule. This is a rotation. Rotate, not rotate. 270 degrees. Okay, our rule is we're going to translate x minus 3 and y minus 4. And then we're going to rotate 270 degrees. So the rotation rule is y, for 270 degrees, is y negative x. All right, so we have our original 4, 1 is our original Q, and when we translate it down 3, we do 4 minus 3, which is 1, and the y value minus 4, 1 minus 4 is negative 3. I'm just going to do all the translations first and then do the rotation. So I have 1 minus 3 is negative 2, and negative 2 minus 4 is negative 6. Then I have 2 minus 3 is negative 1, and 3 minus 4 is also negative 1. Okay, so now we want to do our rotation. So in this case, our y value becomes our x value, so that negative 3, it does with no change, but our x, we're going to make it opposite. So instead of being a 1, it's going to become a negative 1. So our y value becomes the x, and our negative 2 is going to become positive 2. Our y value is a negative 1, and then our negative 1 becomes a positive 1. So here we're going to graph our pre-image and the final result. So 1, negative 3 is our, I'm sorry, no, that's, I need 4, 1. That's the Q prime. So 4, 1 is my Q. 1, negative 2 is the R. And 2, 3 is my S. Okay, so now let's rotate it 270 degrees. And I mean, we're going to move it and then rotate it, and we finally end up with our Q double prime, R double prime, S double prime. At negative 3, negative 1 is our Q double prime. Negative 6, 2 is our R double prime. And our negative 1, 1 is the S double prime. All right, so let's try this again. Given, here, let me leave this so you can see it a little bit still. Given triangle ALT, where A, L, and T are those coordinates, write a rule to translate triangle ALT by the rule XY translates to x plus 3, y plus 2, then reflect over the y-axis, and then finally graph the results. So our original is here. So we could actually do it on the graph ourselves and then write down the points, or just go by the rules and write down the points. I think it's easier to just do the rules, or I don't know. It just depends on the graph. what kind of mood you're in. Okay, so our first rule is we're going to translate x plus 3 and y plus 2. And then we're going to reflect over the y-axis. So if our y-axis is vertical and we want to reflect over it, our y values are going to stay the same, and our x values are going to become negative. Okay, so to me, that's a common sense one. So our negative x's and then our y's stay the same. Okay, so we start off by translating each of our points by the rule. So -5 plus 3, -2. -1 plus 2 is +1. -4 plus 3 is -1. -2 plus 2 is 0. -3 plus 3 is 0. 2 plus 2 is 4. Any questions about what I'm doing there? Okay. Just go ahead and ask, even if I didn't wait for you to answer me. Let me move the chat thing so I can see it, just in case someone does it real quick. I got it right here. Okay, so we are now reflecting over the y-axis, each of our points. So our x value is going to be negative or opposite. Remember, this means opposite. Not just negative. So if I already have a negative, the opposite of that is going to be the +2, and then the y stays the same. The -1 becomes +1, and then the y stays the same. The 0 is 0, so we don't have positives and negatives. But so we end up moving that point doesn't actually move when we reflect it over the y-axis because it's on the y-axis. Okay, so now we're going to plot our final result at 2, 1, which is our A double prime, our 1, 0, which is the L double prime, and then the 0, 1, 2, 3, 4, which is our T double prime. So this has been moved and then reflected. Any questions? Okay. This transformation here. This one is real close to the y-axis, but let's look at our next example. Given the triangle ALT, again, write a rule to reflect over the y-axis, then translate by the rule, and finally graph the results. So again, reflecting over the y-axis, our y values are going to stay the same. Okay, but our x values become the opposite. So x values become the opposite and our y values stay the same. Then we're going to take that and add 3 and add 2 to our x and y. I wanted to write that in red, so I'm just going to write over it. Okay, so we just do the coordinates and then we'll plot it. We have -5, which becomes +5, -1, because the y stays the same. -4 becomes +4, and the -2 stays the same. The -3 becomes +3, and the 2 stays the same. Now we're going to add 3 to our x's, so I have 8. Add 2 to our -1, and we have +1. Add 3 to 4, and we get 7. Add 2 to -2, and we get 0. Add 3 to 3 is 6. Add 2 to 2, and that's 4. And so our A double primes, what we're going to plot. So 1, 2, 3, 4, 5, 6, 7, 8. no, 8, 0, but 8, 1. This is going to be my A double prime. 7, 0 is going to be here, and that's my L double prime. And then 6, 4 is my T double prime. All right, so notice in examples 2 and 3 were the same transformations, but done in a different order. So see this transformation here? And let's look, this one is not, because we flipped it and then moved it, which is different than moving it and then flipping it. So using these as examples, would you say that order matters? Yes. Order matters. All right. So we can do one more. We're going to, triangle TAB is translated 4 units to the right and 2 units down, and then reflected across the y-axis to these points. This is the, notice those double primes. This is the image. So we need to go backwards to find the coordinates of the pre-image. So what we did is we had XY, and then we are going to translate right 4, and, oops, forgot to put X minus 4. X minus, or plus 4, because that's right, and then 2 units down, Y minus 2. Then we reflect over the y-axis, which is where the y's stay the same, but the x's become opposite. So that's negative x comma y. All right, so what happens is we're given all of these points. So T double prime is 410. A double prime is 6, 5. And B double prime is 1, 2. So when we go backwards, when you flip over the axis and then flip back, it's going to be the same transformation. Your y's are still going to be the same, and your x's are still going to be opposite. So that means we're going to still do the negative x y's. Let me change color here so it is easier to visualize. So the reflection, I did green, so negative x y going this way. So we have a negative 4, 10. We have a negative 6, 5. And we have a negative 1, 2. So these were the T prime, A prime, and B prime. Now when we go, keep going backwards, just think we had to add 4 to a number to land on this negative 4. So we're actually going to subtract 4 from this to get the original number that we added 4 to get this one. So here we actually are going to do x minus 4, and we had to subtract 2 to get the 10, so we want to add 2 to get the original. So we want to do the opposite. Okay, so our original T, let me move this over. So A and our B are going to be, so negative 4 minus 4 is negative 8. Y 10 plus 2 is 12. negative 6 minus 4 is negative 10, and 5 plus 2 is 7. Then 1 minus 4 is negative 5, and y2 plus 2 is 4. And so when you think about it, if you have negative 8, you go to the original and you add 4, you now have a negative 4. When you had 12 and you added, oh, this is supposed to be in, when I have 12 and I actually subtract 2, I get 10. All right, so now it says, it didn't say that we had to graph it, but let's just leave it at that. All right, so any questions on how to go backwards? Kind of think about it first and then do it.